Hey, geometry. Let's run through the third 9 weeks review here. Number one, it is a geometric mean. Do you remember setting all that stuff up? Geometric mean. So we have the long leg for the small triangle is going to be x, and the medium leg for the medium triangle. The small leg for the medium-sized triangle is going to be x. It's going to be the same thing, right? So because those two legs are touching each other, we can set up a geometric mean as long over short for the small triangle must be similar to long over short for the medium-sized triangle. You should be able to cross multiply, do the square root, and solve. So you end up with x squared is equal to 40, and you do the square root over both sides, all that good stuff. An airplane, number two, an airplane's flying due south. Due south, remember, you can substitute the word due with directly. So due south, 300 miles. So from the origin, due south, 300 miles. Hopefully that gets you set up. And then there's a wind blowing due west. Which direction is due west? It's directly west. So from here, due west at 40 miles per hour. So we know we're moving 40 this way. It wants to find the resultant speed and direction of the airplane. So what's asking for is from here to here. So what's the magnitude and what is the direction? Remember, we're always going from zero to whatever line we're looking for. So use trigonometry to find that out. Use Pythagorean theorem to find the magnitude out, all that good stuff. Number three, which set of measures could represent the sides of a right triangle? You know those ratios, check them out, or if you forgot those ratios, then you need to use Pythagorean theorem over and over and over again. Number four, a model of a lighthouse has a diameter. Model of a lighthouse has a diameter of 8 inches, and has a height of 18 inches. If the actual diameter of the lighthouse is 20 feet, then what is the actual height? Well, that's another ratio, right? So we're going to do one lighthouse over is equal to the other lighthouse. We can do 18 over 8 is equal to x over 20 and solve. Number five, if you can hear stuff in the background, sorry, it seems like everyone around me right now is getting their yard done. Number five, find the perimeter of a square if the length of its diagonal is 16 millimeters. Five is find the perimeter of the square if the length of the diagonal is 16 millimeters. If our length is going to be 16 millimeters, we can find the edge of a square. We know that both of these are going to be the same, so we can either use Pythagorean theorem to solve that, or we can use some of the ratios that we know. Number six, in the right triangle ABC, where angle C is the right angle, so we know that angle C is the right angle in ABC. A is equal to 7. Remember, when it's talking about the length, it's always opposite the angle. So length A is 7, B is 24, and C is 25. Which equation could be used to find the measure of angle A? We need angle A. We know that this is 90. So look for what we're looking for. Make it so it gives you the options of tangent, sine, and cosine. Don't forget about SOHCAHTOA, right? Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent, right? So use that to figure out number six. Number seven, 24-foot ladder makes a 58-degree angle with the ground. So we have a ladder against a wall, and there's the ground. So we know that the ladder is 24 feet. We know that the angle with the ground is 58 degrees. And we know that this is going to be a right triangle because it's a wall and the ground. How many feet up the wall will it reach? Use sine, cosine, tangent. Use trigonometry to find this value out. Okay. What else do we need? Number eight. Number eight says find the component form. Component form, remember, component form is just x2 minus x1, comma, y2 minus y1, and it gives you 2 points. Number nine, find x to the nearest degree. It gives you this triangle right here. 9 gives you And what is that? 5 and 11, and then x. So we're going to use trigonometry. We have opposite and we have hypotenuse. So I wonder which one is going to use opposite and hypotenuse. I just don't know. Okay, so we're going to do sine of x in this case is equal to opposite over hypotenuse, 5 over 11. When you're trying to undo the sign, remember you have to do the inverse sign of the whole thing, which cancels out that guy. It leaves you with x and ends up with sine, the inverse sine of 5 over 11. Okay. Number 10. Let's see here. Number 10. Find the angle of elevation. Angle of elevation. Remember, angle of elevation is always from whatever the horizontal is up. Angle of elevation. This is that angle of elevation. Find the angle of elevation of the sun if a building 125 feet tall, cast a shadow of 196 feet long. So we know that is 196. Round to the nearest degree. Now, don't forget, we have opposite and adjacent. I wonder which trigonometric function we would use with opposite and adjacent. That looks like, I forgot. So set that up and solve. Remember, we have to do the inverse tangent to get rid of that. Number 11, a ship's sonar finds the angle of depression. Remember, angle of depression goes from horizontal down, so we're looking for this angle right here. We have an angle of depression to the wreck at the bottom of the ocean floor at 13.2 degrees. So here's our little wreckage. And if a point on the ocean floor is 75 meters directly below the ship, so we know that it is 75 meters directly below the ship, how many meters is it from that point on the ocean floor to the wreck? So we know that the ocean floor is 75 meters down. What it's asking for is this information. How far are they from the wreckage? Okay. So use angle of depression. We know that that's not the angle of depression, but we do know that this thing is going to make a right triangle because it says directly down. So we can do 90 minus 13.2 to find this angle measure. Then we have adjacent and opposite is what we're looking for. So what would we use for adjacent and opposite? Adjacent and opposite. Adjacent and opposite. I wonder. So, number 12, a triangular garden has sides measuring. So number 12 says a triangular garden has sides measuring 50 feet, 80 feet, and 100 feet. To the nearest degree, what is the measure of the largest angle? Remember, largest angle is opposite largest side, so we're finding this angle right here. We have all sorts of features to use. Please go through law of sines, law of cosines, all that stuff. Triangular garden, it doesn't say it's a right triangle, so figure out which one to use and solve for that missing angle. Remember, it's got to be a proportion. 13, when the sun's angle of elevation is 76 degrees, we know this is angle of elevation, and it draws a picture for us, great. A tree tilted at an angle of 4 degrees is, so this is 4 degrees, this is 76 degrees. Cast an 18-foot shadow. So we know that this length right here is 18 feet. Find the length of the tree to the nearest tenth of a foot. So we need to know this length from here to here. Okay. Set up your ratios, set up all that good stuff. Use your laws. Number 14. see, I got enough. Number 14 says triangle ABC, measure of angle A is equal to 46, measure of angle B is 105, C is 19.8. Find A to the nearest tenth. Remember, the measure of the angles, it says A, B, C, and then it says find A to the nearest tenth. Remember, A is opposite the A angle. Side A is opposite the A angle. Number 15, in LMN, L is 42, M is 61, and N is 108. Angle N is 108. So it says LMN. Side L is 42 because it's opposite L. Side M is 61, and then it says angle N is 108. All right. So it wants to know what is that side to the nearest tenth. Number 16, a boat is 2,000 meters from a cliff. It draws a picture from you. If the angle of depression, you remember horizontal down is the angle of depression. So when in that picture, the angle of depression is going to be that angle right here. Angle of depression from the top of the cliff to the boat is 10 degrees. So this angle is 10 degrees, right? And we know this is going to be a 90 degrees, so we know that this missing angle is 80 degrees. We know that this is 90 degrees because there's a square, so we can find that degree. Also, you can use that these are parallel lines. This is directly horizontal, this is directly flat. This is our transversal, and we have opposite sides inside of the parallel lines, so these must be equal to each other or congruent. Number, let's see, 17. Do I have enough time? Yeah, number 17. Running out of paper here. Who knew I'd run out of paper? Number 17, it gives you the component form. So go ahead and use the origin as the starting point and use component form, so -3 and 2 to find the second point. It wants you to find the magnitude, which is that value, and the direction, which once again goes from 0 all the way around to that. So we're finding this value and this value. So it should be greater than 180. Okay, that's 180 plus this. Number 18, I think I have enough time. 2 swimmers are observed by a lifeguard in a 30-foot tower above the water. So 18, we're going to draw a picture, 30-foot tower. 2 swimmers are observed by the lifeguard. Swimmer 1, swimmer 2. All right, the lifeguard in a 30-foot tower above the water, so 30 feet. The angles of depression, you remember angles of depression go from horizontal to down, right? So from horizontal down. It says the angles of depression are 12.7. We know this one's going to be 12.7 because it's smaller. And this one, this total one, is going to be 14.5 degrees. How far apart are the swimmers? So we need to find this distance from the outside swimmer to here, and this distance from the inside swimmer to here. We're going to subtract those two to find that distance right there. Right. Number 18, find x. That's another geometric mean problem. So remember that we have a small triangle set up right there, which is 3 and x for the hypotenuse. So 3 for the short leg, x for the hypotenuse. Then we have a much larger triangle where we have x for the short leg, and then we have 11 for the hypotenuse. So set that up with number 19. I'm going to go ahead and stop the video and finish up on another one.